So in my last videos, I had looked at some very simple nested radicals that could be written as infinite products, as shown here. And what I'd like to look at now is a different case of infinitely nested radical that cannot be shown as an infinite product, and that would be this example here. Now, what's different about this one is that we can't go through and solve it entirely recursively or with a different method without recursion. Really, we kind of need to do a combination of both. And the first step in making that happen is to notice its similarities to this expression here. Now here we see that x is equal to the square root of a plus bx. Within this expression we have a reoccurrence of the x term. But we've already defined what the entire x term is, and x is equal to this. So we can simply plug all of this into here, and then just repeat several times, well, infinite times, and we'll get this expression up at the top. Now that we have yielded this expression, we can algebraically manipulate it into a closed form for this infinitely nested radical. The first step to doing this is going to be to square both sides to get rid of the square root. So we square both sides and we yield this expression down here. And then what we do is we subtract bx from each side. So we have a all alone. What this is going to allow us to do is set the equation up to complete the square, which is done in this step. So to do that, we simply add our negative b over 2 squared term to each side, which will allow us to rewrite this expression into a form where we can get only one x in the equation. So after creating this form here, we can notice that it can be written as this expression down here. And instead of x popping up twice, it now only appears once, which is what we really need to get x alone. Our next step is going to be to multiply each side of the equation by 4 to further get this part alone. And after that, we are going to take the square root of each side of the equation. Now that we've taken the square root of each side of the equation, we don't really have x inside a function that's going to be that complex. But we end up with this plus minus solution term on the square root, which we'll have to deal with later because we don't want two solutions and we only want one. The next step is going to be to get our negative 2x term all alone. And in order to do that, we just move b over to the other side fairly simply. And now that we have the equation into this form, we can finally get x to be all alone in the equation, as shown here. And in order to do that, we just simply divide each side of the equation by -2, which yields this form up top. Now that each side has been divided out and algebraically redone following all these steps, we can just figure out which solution we want, the plus solution or the minus solution for the square root. And the solution comes fairly simply. Here in our problem, we're specifically interested in taking the positive roots for these nested radicals. So we can use that to rationalize our decision of choosing plus or minus from this bit here. And in doing so, we find that we get this as our solution for x. Now you can test this with infinitely nested expressions of smaller numbers and things you can deal with on your calculator, and your value for x will converge on this for the more terms that you get inside your nested radical on your computation. And from seeing that x is equal to this formula, which looks strikingly similar to the quadratic formula, we can make a simple conclusion about what our nested radical is going to look like due to equivalence. And we find that therefore this nested radical here must be equivalent to this expression here.